case, it'll be T aluminum and T steel. So that in equilibrium form, T aluminum plus T steel is got equal to T, and we know that twist in the same twist. So twist of S is equal to twist of dA. So twist of S is equal to TS length of S to JS GS. Then bring it back and give me subscript. Looks like this. And we're given the stress, so, or I say, the allowable stress for steel core. So what we can do is we use the T allowable formulas, which is TS, CS, GS, and do the same thing with the aluminum. So CA, JA. So yeah, let me substitute numbers real quick. Let's see, it's 8500. The CS for steel, the C is a 2.25 inches divided by 2, so 1.125 inches. And you notice we need J. So let's calculate J's out here. So J for steel, pi over 2, 1.125 to the power 4. That's 2.51611 into the power 4. G of aluminum on the RS, since it's a 2-layer, we got the out diameters, which is 3 inches, so half of 3 inches is 1.5 to the power 4 minus 1.125 to the power 4, which is 4. So 5.436 inch to the power 4 is what we get for J. That's 2.51611. So by solving this, CS is equal to 19010.6 in inch ounce, and that's 19.0106 in kip inches. For TA, we have 6,500 psi is equal to TA 1.5 divided by 5.436. So TA is equal to 23.556 kf inches. Now we can use this and substitute T into our twist formulas, which by doing so, we'll get 6 inches, 2.51611, 11.2 beat 6. We'll end up getting 3.171 degrees. Now, if you put my numbers right here, you can you wonder how 3.171 degrees come from. Because I quoted this in kip inches, so you need to use that number times E to make sure you do that. So that's for S. So twist for A is 23.556, 96 inches, divided by 5.436, 3.9 e to 6. We're end up getting 6.11 degrees. Now, in this case, we have to choose the smaller degrees in order to fit the flow conditions. So by doing that, we take the 3.71, and we want to convert that back to radians, which is 3.71 pi over 180 in radians. That's equal to T, A, 96 inches, convert that into inches to metric units, and 2.51611, which we already know, and 11.2 e to 6. And by doing so, we end up getting there's 5.6, 3.9. So TA will end up getting 14.1 inches. And you're just doing the same thing, so with 3.71 pi 180 is equal to TS 96 inches, 2.51611, 11.2 e to 6. We end up getting 19.0 inches. And what you're going to do is add them to get T. So 14.1 plus 19.0, 33.1 inches, the correct answer for T. Hope you guys find this helpful. If yes, thumbs up, subscribe, support me on Patreon will also be great. Thanks. Hello guys, welcome to this Home Farm Help. And I'm doing something special today. So if you don't know, I just hit 100 subscribers. So if you have any questions, just click on the link below and put them there, and I will answer them for you. And I do also have a Patreon account right now, so if you can support me, that'd be great. So about that, let's get begins. The problem says a 5-meter long hollow drive shaft has inner and outer diameter of 25mm and 60mm, and the shaft rotates at 180 RPM and is made of steel, for which G is equal to 77.2 MPa, and we know that the twist is 3 degrees. And we'll actually calculate the power and transmitted and the maximum shear stress. So before we solve it, let's quickly write our givens. So we're given that the rod, the drive wire, then we know that it's a 5-meter drive. We know the inner diameter is 25 millimeters, and we know the outer diameter is 60 millimeters, and we also know the J. the material steel, which is not that much importance. But we do care about the RPM in this case, which is 180 RPM. Oh. And we do care about the degree of twist, which is 3%. Oh, 30%, sorry about that. So, what do we know about power? So, power is equal to 2 pi ft. So, F here is related to our rotation speed. T here is the tensions. And 2 pi is 2 times 3.1415. So, that's for P. And for the maximum shear stress, which is using our shear stress max formula, Tc divided by J in this case. And since we given the twist is 3 degrees, we also can use the twist formula, which in this case is TL, J, and G. So after knowing this, you see that we have G in commons. So why not just find the G first? So G is equal to I over 2, and here's C squared is 3. Now what happened is, if you read the problem carefully, it got an inner and outer diameters, which means that it's a hollow in the center. So what we're going to have is a C out to the power 4 minus a C in to the power 4. And you want to be careful that don't write the whole parentheses to the power 4. So after doing that, we got pi over 2. We got 60 e to negative 3 to convert that to meters. And we now see is half of the radius. And that whole thing to the power 4 minus the C in this case, 25 e to negative 3 divided by 2, the whole thing to the power 4. We're basically getting 1.23995 e to negative 6 meter to the power 4. So we got our G. Now, if you read the P formula, is giving us 2 pi ft. Now, the F, as what we say about before, is going to take out RPM. That RPM is not the units we actually needed, because RPM stands for rotation per minute. So what we're going to do is takes RPM and times by 1 over 60. It's 1 minute got 60 seconds, and we end up with the 3 hertz. That's the unit we're going to plug in into RPM. So now we know 2 pi, we know F, and P we don't know. So what we can do right now is we can solve for P. So solve for P. T. Sorry about that. And we actually can get T from our phi, our twist formulas. So twist formula is equal to T, L, G, and G. G and G, one is calculated, one is given. And the length is also given as 5 meters. Therefore, by plugging the numbers, what we'll get is 5, in this case, is equal to radians. Now, we know that twist is 3 degrees, so we need to convert the radian, the degrees of radians. What we're going to do is 3 degrees times pi over 160, because you want the radians, so radians should be on top. We get pi over 60s, or 0.0 by to 36 radians. And now we can actually plug in into our phi. So it will be 0.0 by to 36 radians. That's equal to T, which we don't know. The length is 5 meters. And G, we will calculate already, 1.23395 e to negative 6. And we know G in this case is 77.2 gigapascal, so e to the 9 pascal. So if we solve for T, what we're going to get is 997.609 newton meters. And yes, that's probably where you get where you're stuck in answer TA, and there's the unit you wanted. So solve for P in this case, now we can do it. It's 2 pi ft. If we plug in the F, which is 3 hertz, and T, which is fine, 97.609 newton meters, what we end up is 18804.5 watts. And convert that to kilowatts, we move 3 decimal places to the right, to the left, I mean, it's 18.8 kilowatts. So that's for part A. Now we do tau max is what we need for part B. Therefore, we just gotta submit our T, and for C is 0.03. So we got our 6 millimeter in the first place, and divided by 2 is 3 millimeter, 0.03. And J is 1.23995 e to negative 6. What we're gonna end up is 2.4253 e to 7 pascals, or 24.25 megapascals. Or we can write out to 44.3 megapascals if you want to put it this on calculations. So hope you guys found it helpful, and if you do, feel free to thumbs up and leave any questions or comments, and I'll see you next time. Hello guys, welcome. If you have not read questions, feel free to read it. And if you have already read it, let's see it again. So same time, sometimes I write the givens. So the shaft is 8.2 feet, the P is 210 HP, speed is 300 RPM. We need to find the diameter of the shaft, we know the G, and we know the maximum allowable shear stress, and we know the angle twist must not exceed 30, and the problem says we might track both conditions. So for solutions, the first step to solve is always write what we know, the formulas. So we know that the P is equal to 2 pi ft, We know the maximum shear stress is TC divided by G. We know the twist is given by TL G times G. Okay, that's all we know for now. And we want to convert all the givens into the units rules. So RPM needs to end up being hertz. So to do that, we times by 1 over 60, and we can get about 6 hertz. The horsepower needs to be in inches per pound seconds. So we times by 6,600 inch pound seconds divided by 1 HP. That's 1386000 inch pound seconds. Alright, now we got the units rule on. And based on the equation we have, we can find the T. So search that, find T, because we already know the value of P, which is the one we just talked about right here. We know 2 pi, obviously, and we know F is 6 hertz. So by plugging in the numbers, we'll get 36764.8 inch pounds. And I'm going to introduce a formula you might not know. That is maximum about stress 12 psi is equal to 2C divided by pi C to the cube. So C of Q is equal to 2T divided by pi times 12 psi. So by solving for C and substituting the values we have, we'll end up getting C is equal to 1.2494 prime inches. So D in this case is 2C, this is diameter, is 2.4988 inch. Now something you can get around here is instead of putting 12 each to 3 equals 12. So keeping that in mind, you are giving a KSI, not a PSI. So now we know the problem doesn't answer right here, because the problem says we need to track both conditions. Therefore, the second condition we're going to track, based on the inputs we have, we can track is the twist. So the twist formulas. However, twist is then as 3 degrees, so we need to convert that to radians. So 3 degrees times pi divided by 180 degrees to convert our radians will give us pi over 60, which equals to 0.05359 in radians. So again, put that into our radian spot, and that's going to equal to T, which we just calculated. Now, you may ask me, why we try to solve right now is we try to find the G, because G is equal to pi over 2 C to the power 4. That is going to give us C, which is the radius, and that's going to give us diameter by using diameter equal to 260. So length is equal to 8.2 B times by 12 to convert it to inches, and G is 11.2 e to the 6 pascals. So solving for G, what we're going to get is 6.19895 inch to the power 4, and put that into our J right here. C is going to be 1.40945 inch. We know D is equal to 2C. In other words, 2 times this value right here gives us 2.82 inch. And that's the value we're going to pick for our diameters. I hope you guys found helpful. Feel free to leave questions in the comment sections. And I have Patreon now, so if you can support me on Patreon, that'll be great. I'm trying to get the 10% mark. Alright, thank you guys. See you next time. Hello guys, and welcome. So here's our problem. A standard tension test is used to determine the gravity of a material. And here's our material. We know that the diameter is actually 15 millimeters, and we got a length of 120 millimeters. So when the rod is subtracted to the axial force of 3.5 units, so we got our P equals 3.5 units. Then we know that elongation is meant to be 11 millimeters. So the P is applied in the x direction, so we have a elongation in the x direction that's 11 millimeters. Then it says the decrease in diameters is 0.62 millimeters. So if you look at the diameters, which is now in y, so the changing y in this case is 62 millimeters. This is changing diameter, and it's letting out width. So since we know the tensile force, P in this case, why don't we find the stress? So to find stress, there's P divided 8, which is 3.5 e to the 10 to the 3 newtons, divided by the area, which is pi over 2, pi over 4, d squared. So d we put in 15 millimeters. So if we move that right here, what we're going to find is that sigma is equal to 19.8059 newtons millimeters to the cube. And that's actually equals to 19.8059 megapascal. So yeah, look up conversion from the newton meters squared to megapascal, right? So it's a 1-to-1 ratio. So now this is our stress. What we asked to find is the Young's modulus E, Poisson's ratio, and the shear stress G. However, we have a vocabulary G in this case, so we'll leave that for later videos. So for Young's modulus, we have the formulas in the x direction is given as the stress x divided by E minus Poisson ratio times stress in y divided by E, and minus Poisson stress in Z divided by E. So from there, what we need is the stress in x. So what's that? That can be found using change in length in x divided by the original length. So it'll be 11 over 120. In this case, 0.091667. So E for that, remember the Hooke's law, it'll be sigma x divided by EX, all strings, the Hooke's law. So therefore, we got our sigma x, which is 19.8059 megapascal that we calculated above, divided by the x here, which is calculated, okay? What we're going to get is 216.064 megapascal. So that's our gas minus E. Now for Poisson's ratio, we know that the strain of y is given as the strain of length of y divided by D in this case. So what we're going to get is 0.62 divided by original diameters, which is 15 millimeters. We'll get 0.0413333, and we usually leave that in units. So record that the Poisson's ratio is given as the change in strength of y divided by change in strength of x, and negative of that. So we got a negative 0.041333. So we got a positive number divided by 0.091667. So let me zoom out a little bit and screw up. See right here. So that will give us 0.451 as our Poisson's ratio. So that's the end of this video. If you got any questions, feel free to leave in the comment sections. And I do have Patreon.com, so if you can support, that would be nice. For G, I guess you guys can find it in my upcoming videos, so stay tuned for that. See you guys next time. Hello guys, and welcome. So here's our problems. Feel free to read it. A rectangular material is subject to biaxial loading, so you've got stressing x and stressing y, and that results in normal stress shown right here. So the length of the side, length of x is 100 millimeters, and length of y is 75 millimeters. And we're given the E value of the material and Poisson's ratio. We want to determine the changing length of side AB and changing length of side BC. And the latest we want to specify where it is long and short. So without further ado, let's get started. For our solutions, we know that the change in length of side AB, here we look at AB, is in the x directions. So it will be change in length of x is equal to kind of EX times the length of x. And the change in length of side BC, which you can see is y, right, vertical, will be EY and length y. So one thing you can do here is, I know if you watched my video, like last videos, you might do this. You say this part right here is equal to stress of x divided by E, and you say strain of y is equal to strength of Z, which is negative Poisson's ratio, stress of x divided by E. And you might basically solve for strength x, which in this case, you plug in the stressing x was 120 megapascals, so 120 e to 6 pascals, and E was found again, so 86 e to 9 pascals, and you get 0.001379. And what you do is you directly plug in the formula and use that times by the length of x, and you find out that it does not match the answers that teacher gives you, and you figure out your TA. So the whole reason why this happens is because he did it correctly, he didn't do it completely. So we're going to apply the formulas, which is given as follows. So strain x is equal to stress x divided by E positive minus Poisson's ratio stress y divided by E minus Poisson's ratio stress of Z divided by E. So this part right here, we already calculated as this value, so again there we plug in. However, for the these two variables right here, we need to compute. So Poisson's ratio is 0.34 in this case, and sigma of y by given is 160 megapascals. Now here's another thing I want to pay attention to. The sigma of y is in compressions, so what you want to do is write the negative sign to indicate that it is a compressions. If you put positive here, then you might not match the final results teacher gives you. That divided by E. So Z in our cases, sigma Z, there's nothing but Z, such thing, so it's 0. So this is what we're allowed with. And we compute this in our calculators, we'll get 0.002, and that's change in the stress strength Now, the ground changing length model is equal to this right here. So that times the length of x. So we're going to take 0.002 times by the length of x, which is 100 millimeters. So times 100 millimeters, what we're going to get is 0.2 millimeters. And it's positive. And you see that this amount of x is falling, so it's tension. And it's